Hello, Sonic lovers. Welcome to the channel Gone. Today, I will show you how to configure sub-interfaces with VRF and RIP protocol. As we know, in Sonic, by default, all the ports are in layer 3 and all ports have assigned default IP addresses. So, before starting of the video, I have removed all those default IP addresses. Now, before configuring routers, here are steps written. First of all, I will follow step 1, and this is to create VRF. Now, I will go into the router R1. Now, before creating VRFs, first of all, I will show you the status of IP interfaces by using command show IP interfaces. Oops. As we can see here, Ethernet 0, 4 and 8 are not listed in the table because before starting of the video, I have removed all those default IP addresses. Now I will create VRFs by using command sudo config VRF add and then name of the VRF. In my case, the name of the VRF is VRF red. Now I will create VRF blue by using command sudo config VRF add VRF blue. Now I will check the status of VRFs by using command show VRF. As we can see here, two VRFs have been created, VRF red and VRF blue. Now I will save configurations by using command sudo config save by. Now I will go into the router R1 and repeat the same steps. R2. Yes. Now I will also check the status of IP interfaces by using command show IP interfaces. As we can see here, everything is fine. Now I will create VRFs by using command sudo config VRF add name of VRF, VRF red and then VRF blue. Oops. Sudo config VRF delete. Now again I will create VRF because spellings were wrong. Now I will check the status of by using command show VRF. As we can see here in router R2, two VRFs have been created. Now I will save configuration by using command sudo config save by. Now I will go into the topology. Now I will go to the step 2, and our step 2 is to create sub interfaces. Now first of all I will go into the router R1. Here I will create sub interfaces by using command sudo config sub interface add Ethernet. And which Ethernet should I use? In my case, I am using Ethernet 0 and I will create sub interfaces of this port, which is Ethernet 0. Now sudo config sub interface add Ethernet 0.1. Now I will create another sub interface which is 0.2. Now I will check the status of sub interfaces by using command sudo show sub interfaces status. Here we can see two sub interfaces have been created, 0.1 and 0.2. Now the main interesting thing regarding sub interfaces is that the type is A22.1Q encapsulation. In most vendors, while configuring, we have to enable this command A22.1Q encapsulation. But in Sonic, whenever we create sub interface, the type is A22.1Q encapsulation. And now another interesting thing is that when I have written 0.1, it means VLAN is 1. That Ethernet 0.1 is in VLAN 1 and Ethernet 0.2 is in VLAN 2. If I write Ethernet 0.10, then VLAN would be 10. So Ethernet 0.1 is in VLAN 1 and 0.2 is in VLAN 2. Now I will save configuration by using command sudo config save. Now I will go into the router R2 and repeat the same steps. Sudo config subinterface add Ethernet 0.1. Now 0.2. Now I will save configuration by using command sudo config save by. I am saving configurations again and again because unfortunately or suddenly if my switch stops working or reboots, then configurations will be saved. Now again I will go into the topology. Here our second step has been completed. Now I will go to the step 3, which is I will bind interfaces with VRF. But before this, I will check the status of sub interfaces in router R2 by using command show subinterfaces status. Here we can see everything is fine. Now I will go into the router R1. Here I will bind interfaces with VRF by using command sudo config interface VRF bind Ethernet. In my topology, Ethernet 4 is in VRF red. Ethernet 4 is in VRF red. And Ethernet 8 is in VRF blue. Now I will save configuration by using command sudo config save by. But before saving configurations, one thing I have to assign VRFs to sub interfaces as well. Ethernet 0.1 is in VRF red and 0.2 is in VRF blue. Now I will bind VRF red with 0.1 also. 0.1 and with 0.2 VRF blue. Now I will save configuration by using command sudo config save by. Now I will go into the router R2 and repeat the same steps. Sudo config interface VRF bind Ethernet 4 with VRF red. Ethernet 4 with VRF red. Yes. Ethernet 8 with VRF blue. Now I will bind subinterfaces 0.1 with VRF red and 0.2 with VRF blue. Now again I will save configuration by using command sudo config save by. Now I will check the status of VRF by using command show VRF. As we can see here, everything is fine. Now I will go into the router R1 and here I will check the status also by using command show VRF. As we can see here, everything is fine. Now I will go to the step 4. This must be the step 4. This must be the step 4. This must be step 5. This must be the step 6. Sorry, I had made a mistake. Now I will assign IP addresses to interfaces. Now I will go into the router R1, sudo config interface IP add Ethernet 4. Ethernet 4 I have to assign 10.1. 192.168.10.1/24 to Ethernet 8 Ethernet 8 11.1 11 now to Ethernet 0.1 14.1 Ethernet 0.1 Ethernet 0.1 I will assign 14.1 and to Ethernet 0.2 I will assign 15.1. Yes, here 15.1. Now I will save configuration by using command sudo config save by. Now I will check the status of IP interfaces by using command show IP interfaces. Oops. Spellings are wrong. Now here we can see Ethernet 0.1 have been assigned IP 14.1. Ethernet 4 is 10.1 and everything is fine. Now I will repeat the same steps on R2. These are two here. Sudo config interface IP add Ethernet 4.192.168 with Ethernet 4 12.1 12.1/24 with Ethernet 8. I will assign 13.1. Here 13.1, yes, 13.1. With Ethernet 0.1, I will assign 14.2. 14.2. 14.2. With Ethernet 0.2, I will assign 15.2. Now I will check the status of IP interfaces by using command show IP interfaces. Yes, everything is fine. Now I will save configurations by using command sudo config save by. Now I will again go to topology. Now I will go to the PCs and check the status of IP addresses. I will go to the PC4, PC1. I will go to the PC1. Yes, I will assign IP 192.168.10.2/24 192.168.10.1, which is gateway. Now I will check the status of IP address by using command show IP. So IP address have been assigned. Now I will check the status of IP on PC4. PC4 show IP. Before starting of the video, I have assigned all the IP addresses to the host. Since it is a redundant work, to save time, I have assigned IP addresses to PC2, PC3 and PC4 before starting the video. Now, our stuff IP is run RIP protocol. Now, I will go into the router R1. Before going into the RIP protocol, let me tell you one thing. The architecture of Sonic is designed in such a way that FRR is integrated in Sonic. First of all, we have to go into the BGP container and then start a daemon process which will run in the background. Now I will go to the BGP container by using command docker exit it bgp bash cd/user/lib/frr ls rip daemon. As we can see here, RIP process is running in the background. Now I will repeat the same steps in router R2. Docker exit it bgp bash cd/user/lib/frr ls rip daemon. Now, as we can see here, RIP daemon is running in the background, or RIP process is running in the background. I will go into the router R1. I will exit out, dash, configuration mode, router, RIP, VRF, and then name of VRF, VRF red. Network 192.168.10.0/24. I will advertise all those networks which are directly attached with router R1. With router R1, then the networks are attached 10.0 and 14.0 because these two networks are in VRF red. So I will advertise these networks because I in VRF red instance 10.0 and then 14.0. 14.0. Exit. Now I will go into the VRF blue. Now I will advertise 192.168 11.0 and 15.0. I will advertise these two networks because these two networks are in VRF blue and these are directly attached with router R1. 11.0 and 15.0. 11.0/24, 11.0 and 15.0. Exit, exit, right. I have saved configurations by using write command in /etc/frr directory, and the name of file is ripd.conf. Now I will check the status of RIP protocol by using command show IP RIP VRF and then name of the VRF red. Here we can see 10.0 and 14.0 are directly connected with router. Now I will check the status of VRF blue. So yes, everything is fine. Now I will go into the router R2 and repeat the same steps. I am already present in configuration mode. I will use command router rip VRF red. I will advertise network 192.168. I will advertise networks 12.0 and 14.0. 12.0 and 14.0. Yes, now exit. Now I will go into VRF blue instance. VRF blue. Now I will advertise networks 13.0 and 15.0 because these are in VRF blue. 13.0 and 15.0. 13.0 and 15.0. Now exit, exit, right. Now I will check the status of RIP protocol by using command show IP RIP VRF red. Yes, as we can see here, it is showing C and C. C means these two networks are directly attached with the router. What does R mean? Here R means RIP route. This route is actually a RIP route, means this route is present in the routing table of R2 due to RIP protocol. As we can see here, with R2, only these networks are directly attached. But now we can see 10.0 is also present because we have used RIP protocol. RIP protocol has advertised this network. Now I will check the status of VRF blue. VRF. Yes, we can see here 11.0 route has also been advertised by RIP protocol to router R2 and it is present in the routing table of R2. And now I will show you one more thing. For 10.0, the next hop is 14.1. For 10.0, the next hop is 14.1 because 10.0 is also in VRF red and 14.0 is also in VRF red. So R2 will reach to this network through 14.1 because these two networks are in same VRF. As we can see here, for VRF blue 11.0, router R2 can reach 11.0 through 15.1. Router R2 can reach 11.0 through 15.1 through this port because these two networks are in same VRF. Now I will check the status of these routes on router R1 as well. I will go into the router R1. Here I will check the status by using command show IP RIP VRF red. Yes, as we can see here, route 12.0 has also been advertised by router R2 through RIP protocol 12.0 and the next hop address is 14.2 and the next hop address is 14.2 because 10.0 and 14.0 are in same VRF and router 12.0 and 14.0. Now I will check the status of VRF blue. Here we can see 13.0 has also been advertised through RIP protocol and the next hop address is 15.2 because 15.0 and 13.0 are in same VRF. As viewers can see here it is showing an error, daemon error. Actually, due to less resources, my switches were stuck. Now I have again restarted my switches, and then again I have started RIP daemon process, which is running in the background. Now I will generate a ping request from PC1 to PC3. I will go into the PC1 and I will generate a ping request for PC3. PC3 is 12.2. Ping 192.168.12.2. Yes, thanks God. Configurations were very long. As we can see here, PC1 is getting reply from PC3 because these two are in same VRF. And the one most thing we must note is that TTL is decremented by 2 because PC1 is getting reply from PC3 after passing through two hops, router 1 and router 2. These are two hops. So after passing through these two hops, TTL is decremented by 2. Now I will generate a ping request for 13.2. 13.2. As we can see here, PC1 is not getting reply from PC4 because PC1 and PC4 are in different VRF. It is in VRF red and it is in VRF blue. As we can see, it is showing unreachable because packets cannot be sent to PC4 because these two are in different VRF. Now I will generate a ping request from PC2 to PC4 because these two are in same VRF. PC2 to PC4. PC2 here PC2. PC2 to PC4 13.2. Ping 192.168.13.2. As we can see here, PC2 is getting reply. PC2 is getting reply from PC4 because these two are in same VRF. PC2 and PC4 are in same VRF. Now I will generate a ping request for 12.2. As we can see here, PC2 is not getting reply, is not getting any reply from PC3 unreachability because these two are in different VRF. And the one most important thing we must note, TTL again is decremented by 2 because there are two routers, and whenever packet passes through router, TTL is decremented by 1. So everything is fine. Subinterfaces with VRF and RIP protocol has been configured successfully. Now, before stopping this video, let me show you one more thing by going into the router R1. Router R1. Now, I will check you the status of RIP configuration file by going into docker exit it tcp bash cd /etc/frr ls. Here we can see we have ripd.conf file. Now I will cat ripd.conf. As we can see here, all the configurations of RIP protocol have been saved here. As we can see here, router RIP VRF blue, the router RIP VRF. Now let me show you one more thing before completing this video. Now I will show you the status of config.db. cat /etc/sonic/config.db.json file. Here config.db.json file is a file where all the configurations are saved. All the layer 3 configurations are saved in /etc/frr directory. And all layer 2 configurations are saved in config.db.json file. Yes. As we can see here, VRFs have been created, VRF blue and VRF red. Here we can see the IP address of Ethernet 0.2 here. Here we can see the configurations. VLAN subinterface 0.1, admin status VRF name. Here we can see all the layer 2 configurations are saved in config.db.json file. Actually, all the layer 3 protocols like RIP, OSPF, which have daemons. As we know, since FRR is integrated in Sonic, in FRR we have daemons. So all the configurations regarding daemons for L3 protocols are saved in uh, /etc/frr directory, while layer 2 configurations are saved in config.db.json. Here we can see all the configurations have been saved. So thank you guys for watching my video. If you want more videos like this, kindly subscribe my channel.